I will do a brief introduction of our project in terms of problem background, aim, objectives, and scopes. For problem background, in today's rapidly evolving technological landscape, computer performance plays a critical role in determining efficiency and productivity. With a wide range of computer hardware options available, it can be challenging to accurately analyze and compare system performance. So this is where benchmarking comes. For M, this benchmarking research aims to compare two different computer systems' performance using the benchmarking program. We can able to determine the system advantages and disadvantages according to this research, which will help us to choose the right hardware for particular use cases. So for objectives, our objectives of our project is to precisely measure and compare the performance characteristics of two computers. Consider RAM size, speed, latency, and effect of memory timings. Examine future important hardware parts and to analyze each computer system CPU performance. For the scope, we choose two computer systems designated as System A and System B. The complete hardware specifications for each system, including the CPU, GPU, RAM, storage, and other essential parts, will be provided. The testing procedure will be done by using CPU jack and HW monitor to evaluate CPU, memory, and hardware performance. For HW Monitor, it is a free hardware monitoring program that monitors the speed, voltage, temperature, fans of PC connected to your network. Whereas CPU Jack is a freeware system fulfilling a monitoring application for Microsoft Windows that detects the central processing unit, RAM, motherboard, chipset, and other hardware features of a modern personal computer. These two benchmarking tools can help us to identify areas where improvements can be made by. So for part 1, we will explain about overview, the flowchart of the project, benchmarking result, analysis, comparing, and discussion. For 2.1 overview, we will focus on using benchmarking tools to compare the two different Windows-based computers or notebooks. We select two benchmarking tools after viewing the video given by the lecturer, which are CPU-Z and HW monitor. After that, we also choose two Windows-based computers to do the benchmarking. The flowchart will draw based on the procedure of the benchmarking, and the result will also be recorded after we do the analysis, comparison, and discussion. So from here, we can see the strengths and weakness for each of the computers. For the flowchart part, first we choose two different computers for benchmarking. Then we download and install two different benchmarking tools. And we charge power mode of the computer to best performance. Then execute the benchmarking process with selected computer. Collect the record benchmarking results. And last, we analyze and compare the benchmarking result of two computers.
I'm Changyan Lee, and now I'm going to present the benchmarking result. In this project, two devices are chosen from our group members to be benchmarked. We consider several aspects for benchmarking, such as the processor, concentrate, clock speed, clock multiplier, cache, and multi-thread ratio, as shown in the table. In this project, the devices used are laptop C1P8QGLU and laptop E653NQQE. The processor of each device is Intel Core 11 generation i5-1135G7 and i7-1165G7 respectively. They have the same number of cores and threads at different clock speed, which is 2.4 gigahertz with multiplier of 15 and 2.8 gigahertz with multiplier of 23. The cache size of i5-1135G7 is 8 megabytes, while for i7-1165G7 is 12 megabytes. Lastly, the multi-thread ratio of i5-1135G7 is 4.02, while for i7-1165G7 is 3.54. So this is the benchmarking result of the two devices using two benchmarking tools which are CPU-Z and HW monitor. The benchmarking result will be discussed in detail in subsequent sections. In this section, we present about the result analysis. So these two are the benchmarking test results from the benchmarking tool. It shows that the two devices have 4 cores each in the CPU. The average core speed for i5-0135G7 is approximately 1496.67 MHz, while for i7-1165G7 is 2291.77 MHz. This has defined the capability of each core to execute independent instructions for multitasking. Then the i5-0135G7 has a clock speed of 2.4 GHz with clock multiplier of 15. So it will have the maximum turbo frequency of 42 GHz, while i7-1165G7 has 2.8 GHz clock speed with clock multiplier of 23. Therefore, it has the maximum turbo frequency of 47 GHz. The gauge for the i5-1135G7 is 8 megabytes, while the i7-1165G7 is 12 megabytes. The L1 and L2 cache for both processors are the same. The L3 cache for the i5-1135G7 is 8 megabytes with 8-way set associative, while the i7-1165G7 is 12 megabytes with 12-way set associative. The larger cache size and number of sets allow the CPU to access the data more quickly rather than accessing through the main memory. For the multi-thread ratio, i5-1135G7 is 0.02, while the i7-1165G7 is 3.54. It is a measurement of the speed, efficiency, and overall performance of the system under control conditions. This test, the single thread for the single thread execution for the i5-0135G7 is 513.2 and its multi-thread execution is 2061.4, while the i7-1165G7 is 226.4 and 802.2 respectively. So that is all for the result analysis. The following section will compare the result for both devices. This table has shown that the comparison of the differences between the two devices. So here are some details about the device, processor, cores, and threads. So for the clock speed, we can see that the clock speed and the multiplier of the i7-1165G7 is higher than the i5-1135G7. It allows the CPU of the i7-1165G7 to be able to execute more instructions per second to achieve a higher maximum clock speed than the i5-1135G7 when carrying out some workloads. Besides, the i7-1165G7 has a higher cache size than the i5-1135G7. This has provided a better system responsiveness for the i7-1165G7. For the multi-thread ratio, the i5-1135G7 has a higher ratio than the i7-1165G7 in the bench test. This shows that the i5-0135G7 has better performance of multi-core processors and multi-threaded software applications than the i7-1165G7. So there will be all for the comparison. The following section will present about the discussion. By going through the analysis and comparison, we have gained the conclusion that the i7-1165G7 has an overall higher evaluation and better performance than the i5-0135G7. The i7-1165G7 has a higher clock speed and clock multiplier than the i5-0135G7. This enables the processor to achieve a higher frequency during the execution. The i7-1165G7 also has a larger cache size and number of sets than the i5-0135G7. Hence, the CPU can have a higher flexibility of data accessibility to access the data more quickly in a shorter time. In conclusion, the i7-1165G7 has better performance than the i5-0135G7. The Intel Core i5 provides an all-purpose processor for a device while i7 provides a higher processing power in operation. A CPU with good performance is definitely preferable. However, the overall balance, performance, cost, and specific requirements by the user should also be considered.
Alright, so for part 2, we are going to execute this assembly language code into both laptop that we attest. So first we initialize the value of x with 7s because our group is group 7s. And then at the last line we can see move ECX hundreds. It means that we will do or we will run this code hundreds time. And then we continue to line 33 until 65. This is the loop. This is the code inside the loop. So at line 59, we increase the value of s with 1. And then at line 62, we increase the value of I with 1. So after that, at line 64, we compare the value of ECS with I. If the value of I is greater or equal to hundreds, the loop will terminate. Otherwise, it will do the loop. So we continue to line 67 until 91. So at this part, we display the result at line 68 until 72. At line 76 until 78, we calculate the CPU elapsed times by subtract the value msec1 with msec2. And then at line 81 until 85, we display the CPU time, and then is it. That's it. So this is the benchmarking result after we execute the code into both laptop, Asus VivoBook and Asus Switch. So actually we take 3 reading, and then we calculate the average reading. So at the average reading, we can see that Asus VivoBook has 1,444,655.67, and then for Asus Swift, it get 7,342,895.67. And then what we can summarize is that Asus VivoBook has the lowest compared to Asus Swift CPU elapsed time.
For this analyze part, we will analyze the result of CPU elapsed time that we obtained by executing the program in device 1 as a Swivel book and also device 2 as a Swift. So we will use some formulas to get some answers. For the first one is formula to calculate the performance of both device. So you can see the answer beside the formula. For Asus VivoBook, we obtain 0.000006919, and for the Asus Swift, we obtain 0.000001362, and then the second formula is to for calculate the performance ratio between the Asus VivoBook and Asus Swift, and the answer we got is 5.079. And then we use the third formula to analyze the to calculate the speed ratio between the SS VivoBook and SS Swift. So the result is we can see there 5.08, and then the last formula we used to calculate the percentage of speed. So the answer we got is 408%. In this comparison part, we use the result we got from the analysis part to compare the both devices. For the first value we got is performance value. The higher the performance value, it shows the better performance of CPU of a device. So in this case, it will SS we will book as a better performance compared to the Swift, because as we can see that the performance value of Asus VivoBook is higher than the Asus Swift. And then the second one is performance ratio between the SS VivoBook and SS Swift. We obtain from the analysis part is approximately is 5.079. So this shows that SS VivoBook performs roughly 5 times better than the SS Swift. So the third one is a speed ratio we got from the analysis is also the 5.08. So this shows that Asus VivoBook is 5.038 times faster than the Asus Swift. After we calculate the speed percentage, we change to the speed percentage, we get this 408%. So that's all for the comparison. The analysis and comparison suggest that the Asus VivoBook outperforms the Asus Swift in terms of CPU elapsed time and also the overall performance. So in this discussion part, we will discuss the factors, some factors that contribute to the performance difference between these both devices. So the first factor that contribute in the difference of performance is actually the processor model of both device. The SS will look as processor i7, which is higher end model compared to the Asus Swift, which have i5 processor i5. So this offer the better performance due to its higher specification. And then for the second factor is clock speed of the both devices. The Asus VivoBook has a higher base clock speed of 2.8 GHz compared to the Asus Swift base clock speed of 2.4 GHz. So the higher clock speed enables faster execution of instruction, resulting in better overall performance in the Asus VivoBook. And for the third factor is actually the clock multiplier. Clock multiplier is will determine the maximum frequency of a processor that can achieve under certain conditions. So SS we will look as a higher clock multiplier, allowing it to reach a higher maximum turbo frequency of 4.7 GHz compared to the Asus Swift maximum turbo frequency of 4.2 GHz. So this shows that the SS Book, which have i7, can handle demanding tasks more efficiently than the SS Swift. And then the last factor that lead to the faster execution of code of SS VivoBook because of its cache. The SS VivoBook is has a largest cache size compared to the SS Swift. So as all we know, a large cache allows for quicker access to frequently used data and also reduce the time taken to fetch the data from the main memory. So that's can improve the overall system of the SS book. So in overall analysis, the SS book is more powerful and capable processor compared to the SS Asus Swift.
So, in conclusion, we conducted two types of CPU benchmarking. First, we utilized CPU Z and HW monitor tools to explore benchmarking capabilities. Second, we wrote an assembly code to measure the time it takes to execute a given math equation with a loop running hundreds times. The goal was to determine whether the loop Asus VivoBook, which used Intel i7 processor, or laptop Asus with which used Intel i5 processor, is more efficient in terms of CPU performance. After completing all the benchmarking tests, we can confidently conclude the laptop Asus VivoBook outperformed laptop Asus Swiss in CPU benchmarking. Reflection. From this project, we learned how to benchmarking CPU using two methods. First, using CPU Z and HW monitor tools. Second one, we execute assembly code for a map equation. This project allows us to compare CPU performance using different tools and analyze their capabilities at a lower level through assembly code execution. Challenges may arise, but they provide valuable learning opportunities to us.
Through this project, I gained valuable insight into benchmarking and the importance of computer performance. It's really fascinating to learn about the importance of computer performance and how benchmarking can help users make informed decisions when choosing hardware components. One of the key things I learned from this project is the significance of CPU specification in determining overall system performance. By analyzing variables such as cost, threads, clock speed, cache size, and multi-thread ratio provided valuable insight into the capabilities of each CPU. This project also greatly enhanced my understanding of my course, computer architecture and organization in Chapter 8. It provided a practical application of the knowledge I acquired, allowing me to connect theoretical concept taught in my course with practical implications. Furthermore, I think I can make better decisions in future when selecting hardware components or devices that perfectly align with my specific needs, like multitasking, gaming, or content creation, etc. That's all from me. Thank you.
In our benchmarking project, we compared the CPU performance of two Windows-based laptops. We evaluated their effectiveness and power with the aid of CPU jack and HW monitor. Lower CPU elapsed durations imply faster and more efficient processor, whereas higher CPU and FPS ratings suggest superior overall performance. Through this effort, we gain a deeper understanding of CPU benchmarking, which can help us to choose the best computer hardware.
Benchmarking of CPUs evaluates and compares between the performance of the CPUs in order to select a device that is most suitable for oneself. It evaluates strength of the CPU and measures the CPU time for executing a program. The CPU elapsed time is the time taken from the start to the end for a program. A short elapsed time indicates a faster response time during the interaction between CPU and the user, while a long elapsed time takes more concern on CPU performance rather than the user experience. All in all, the user's requirement for a CPU should always be the main concern to be considered.